without me. Don't you tell me what I supposed to do when I'm walking on.
Welcome guys to today's class. In today's video, we want to solve possible exam questions on the topic alternating current circuit, as you can see on the board. Yes, on our YouTube channel, Chidon's Daniel YouTube channel or the Chidon's Academic class, you will see the theory aspect of this topic, alternating current circuits. We discuss a lot of things on this topic. And so we want to see how to solve questions, exam questions on this topic. And that is the focus of this video. Yes, let's start from question number 1. A 200 watts laptop is connected to a 240 volt AC line. Calculate the root mean square current flowing from the outlet. B. Calculate the peak current and peak voltage. C. Calculate the maximum power delivered. Now, if you want to solve this question, there are important points we talked on that video. We said that V root mean square voltage, that root mean square voltage is equal to what? VO over root 2. We also said that I root mean square current is equal to what? IO over root 2. What do we mean by VO and what do we mean by IO? IO means the peak current or the maximum current. Peak or maximum, they are synonymous. Peak current or maximum current. Then VO means peak voltage or maximum voltage. Look at how they are related. We also said that there is what we call average power. Average power. The average power is equal to I root mean square current times what? V root mean square. Then there is also what we call maximum power. Maximum power or peak power. Or peak power. That one will be going with what? Peak current and peak voltage. Peak current times peak voltage. Can you see now? This average power and maximum power are not the same. It is important to have this in our mind as we go about solving this. They gave us a 200 watts. That means power is equal to 200 watts. Then the voltage equals to what? 240 volts. But they are asking you calculate the root mean square current flowing from the outlet. That means that the power they are giving you is called average power. Average power. And the V they gave you is root mean square what? Voltage. Now you have to use average power equals to root mean square current times root mean square voltage. That means root mean square current being this, I root mean square current will be equals to average power. Average power divided by what? V root mean square voltage. And what is your average power? Average power is equals to, they gave it to you to be 200. Then the V root mean square voltage is 240. Then you use your calculator and compute it. You have 0.83 ampere. The unit of root mean square current is amps. Then we go to the next question. Determine the peak current. Determine the peak current and peak voltage. If you are able to what? Get your root mean square current, you can get your root mean square what? You can get your peak current or maximum current. How do you do that? You tell them that therefore maximum current is equal to root 2 times what? I root mean square current. So root 2 times what is our I root mean square current? We got it to be what? 0.83. That will be giving you 1.17 watts ampere. We note that. So we have solved question number A and B of the first question. Oh, we still remain peak voltage. How do we solve peak voltage? You say peak voltage equals to what? Root 2 times what? Root mean square what? Voltage. Root 2 times root mean square voltage. What is root mean square voltage? 240. Therefore, VO equals to 240 times root what? 2. 240 times root 2 will be giving you what? 339. 339 point what? 4 volts. Okay, so we have gotten our what? Peak current, peak voltage, root mean square what? Current. We know our root mean square voltage, and that is all. Then calculate the maximum power delivered. I said before now that average power is I root mean square times V root mean square. Maximum power or peak power is this. But do you know that V root mean square is equal to VO over this, right? That is, that VO is root 2 times V root mean square voltage. What do we mean, or what are we saying? IO is equal to what? Root 2 times I root mean square current. VO is equal to root 2 times V root mean square voltage. And so if you multiply both of them, that will be giving you that maximum power will be equal to 2 times V root mean square voltage and what? I root mean square current. Okay, let's understand what we are saying here. We are saying that we noted that VO is equal to what? Root 2 times V root mean square. We say VO equals to root 2 V root mean square. IO is equal to root 2 I root mean what? Squared. Noted. Now, maximum power simply means IO times VO. That means this times this. We'll be having maximum power to be equal to root 2 V root mean square voltage times root 2 I root mean square current. That is what we just wrote here. Root 2 times root 2 will give you 2. That means we'll be having it to be 2 times V root mean square voltage times I root mean square current. That means, since we noted that V root mean square voltage and what? I root mean square, that when you multiply both of them, you have average power. Now, maximum power means 2 times the multiplication of these two. That means that maximum power, mass power, is equal to 2 times average what? Power. I just want to remind us this information because we discussed it in the theory of this topic. I said we have posted it on the channel. So what I am saying is that if they ask me to find maximum power, already they have given me the average power in the question. I'll just say maximum power equal to 2 times what? Average power. That will be giving me 400 watts. I will not waste my time. So if we multiply I root mean square times this, what it will give you is 0.83 times what is your V root mean square? 240. That is, we have done this. I root mean square 0.83, V root mean square 240, then times 2. Times 2. You'll be having 398.4 watts. 398.4 watts. That is from approximation. That means approximating it to nearest 100. Okay, to nearest tens will be giving you 400. 398.4. 398.4 to nearest tens means ask 8, are you up to 5? Yes, call it 1, put it here. You have 0, put it here, 4. So it gives you 400. But the simplest way of solving it is, having noted that average power, which is this times this, when you multiply by 2 is maximum power. Multiply that average power by 2, you get your answer. Do you understand what we are saying? Okay, so that means the maximum power is 400 watts. The peak voltage, we said the peak voltage is equal to I2 times V root mean square, and that is 240 times what? Root 2. Then the peak current is equal to I equals to root 2 times what? I root mean square. That is root 2 times 0.83. That is about 1.17 ampere. Then root mean square current, we said, is equal to average power over what? V root mean square. Average power over V root mean square. And that will be giving you 200 over 240. That gives you 0.83. So we have solved question number 1. We go to question number 2. A root mean square current of 5 amps. You say I root mean square equals to 5 amps. flows through a 10 ohm resistor, you say, wow, R equals to 10 ohms. Calculate the average power absorbed by the resistor. Calculate the average power absorbed by the resistor. Wow. That means if we want to solve this, we remember that V root mean square is equal to I root mean square times what? R. From V equals to IR. Then that means we will get our V. Our V is equal to 5 times what? 10 equals to 50 volts. Have it to be 50 volts. That is the root mean square voltage. Why are we getting our V root mean square? We are getting it because power, average power is equal to I root mean square times V root mean square. So that is why we are getting it. So we will say, what is our I root mean square? 5 times V root mean square 50 equals to 250 watts. Then question number B, calculate the peak current across the resistor. If we can get our I root mean square, we can get our peak current. Okay, if we can get our I root mean square, we can get our peak current. That means our peak current is equal to root 2 times I root mean square. What is our I root mean square? 5. Okay, we say 5 times root what? 2 equal to 7.07 watt amps. Okay, so that is our what? Peak current. Then if they ask us to find peak voltage, if they also ask us to find peak voltage, in this place they didn't ask us, but if they ask us, say peak voltage is equals to, we have our V root mean square to be 50, we have it to be peak voltage equals to root 2 times V root mean squared. That is about peak voltage. That means root 2 times V root mean square is what? 50. 50 root 2 will be giving you 70.71 volts. So that is when they ask you peak current, peak voltage, then average power. This is how you can solve it. Let's go to question number 3. A 50 microfarad capacitor is connected to a 60 hertz source that provides 24 V root mean square. Find the peak charge on the capacitor and find the peak current in the wires. Now, first and foremost, what do we mean by peak charge? We say peak charge means QO equals to CVO. So if we are talking about peak charge, we'll be talking about peak voltage. Now, how do we get our peak voltage? We are given the V root mean square. And since we are given the V root mean square, we'll say peak voltage is equal to root 2 times V root mean square. And that will be root 2 times what? 24. We'll have it to be equals to 33.9 volts. That is your what? Peak voltage. That means the peak charge should be equal to 33.9 volts times what is the capacitance of the capacitor. The capacitance of the capacitor is 50 microfarad. That means 50 times 10 raised power minus 6 watt farad. Micro means 10 raised power minus 6. So we have this times is to be 33.94 volts. 94 volts. And so we will be multiplying it by this. 33.94 94 times 50 times 10 raised to the power of minus 6. That will be giving us 0.001697. What is the unit of charge? Coulomb. Unit of charge is coulomb. So that is the peak charge on the what? Capacitor. Peak charge is directly proportional to peak voltage. Okay? Then peak current. For you to get peak current, remember that peak voltage is equal to what? Peak current times R. But in this question, we are not given the resistance of the resistor. The effective resistance of the resistor, it is not given to us. We are given capacitor. So that means our R will be equal to XC. That is the capacitive reactance. Yes, because it is capacitor that they talk about here. So capacitive reactance will be our R. And it's equal to 1 over 2 pi LC. 1 over 2 pi LC. So how do we compute it? We'll say 1 over 2 pi times F is what? Frequency 60 times C is 50 times 10 raised to the power minus 6. So press 2 shift pi times 50 times 60 times 10 raised to the power minus 6. We'll be having it to be 0. So we'll get the inverse of it. We'll have it to be equals to 50 watts, 3.05 ohm. Because we said capacitive reactance is opposition to flow of electric current. Inductive reactance also opposition to flow of electric current. So capacitive reactance is opposition to flow of electric offered by the capacitors. Inductive reactance is opposition to the flow of electric offered by the what? Inductors. So we have this. That means our peak current will be equal. What is our voltage? Peak voltage is equal to 33.94. 33.94 all over our, we claim this and replace it with SC now. Our XC is equal to 53.05 equals to IO. So we will be saying 33.94 divided by what? 53.05. That will be giving us 0.64 approximately. 0.64 amps. Okay, so we have said in question number 3, we just solved that when you are asked to get peak charge, say that peak charge is directly proportional to peak voltage, then take your peak voltage, which you have gotten by root 2 times V root mean square, then multiply it by the what? The capacitance of the capacitor. Micro means times 10 raised to the power minus 6. Milli means times 10 raised to the power minus 3, but they say micro. So write 10 raised to the power minus 6. You just multiply them, press your calculator well, and you get this to be your answer. Then come to your what? Peak current. Peak current or maximum current simply mean peak voltage equal peak current times what? R. What will be your R? Capacitive reactance, because the capacitor is what is given to us. The capacitance of the capacitors is what is given to us, and the frequency. So you get your capacitive reactance with 1 over 2 pi FC. You have it to be 1 over 2 pi times 60 times 50 times 10 raised to the power minus 6. Whatever you get, you plug it here. Say VO divided by XC will give you a peak current. Let's solve question number 4. At what frequency in hertz is the reactance of a capacitor with C equals to 100 microfarad be equal to the reactance of an inductor with L equal to 10 millihenry. Remember we say milli is 10 raised to power minus 3. Micro is 10 raised to power minus 6. Okay. Remember that when Xc is equal to Xl, we call this capacitive reactance. We call this inductive what? Reactance. Whenever they are equal, the frequency we got is called resonance frequency. How do we get that? This is 1 over 2 pi Fc equals to 2 pi Fl. Making F subject to formula, this F will come up, 2 pi L will come down. We have 1 over 2 pi C times 2 pi L equals to what? F squared. Then this will be 1 over 4 pi square LC equals to F squared. Therefore, the resonance frequency will be equal to what? Square root of 1 over what? 4 pi square LC equals to 1 over 2 pi root LC. 1 over 2 pi root LC, because square root of 4 is 2, square root of pi square is pi. The LC do not have square root, so package it. So I will be saying that 1 all over 2 pi root, what is my L? 10 times 10 raised to power minus 3. What is my C? 100 times 10 raised to power minus 6. I will simplify this. Now, how do we simplify it? Write square root bracket, multiply this. 10 times 10 raised to power of minus 3 times 100 times 10 raised to power minus 6. Close the bracket. That will be giving you square root of bracket 10 times 10 raised to power minus 3. Then 100 times 10 raised to power minus 6. That will be giving us 0.001. This gives you 0.001 times what? 2 pi 1 over equals to FO. FO will be equals to, you now say 2 shift pi times 0.001. That will be giving you an answer. Then get the inverse of it. That will be giving you 159.2 watts hertz. So once you multiply the denominator, get the inverse of it, it gives you this. That is how to get the resonance frequency of these words. Question number 4. Now let's solve question number 5. A series RLC circuit with R equal to 10 ohms, L equal to 0.2 millihenry, and C equal to 0.008 microfarad is connected to an alternating voltage. If the amplitude of the alternating voltage source is 3 volts, calculate the resonance frequency of the circuit and amplitude of the alternating current at resonance. Because they asked to get the resonance frequency of the circuit, just tell them FO equals to 1 over what? 2 pi root LC. That is just the formula. 2 pi root. Your L is what? 0.2 times 10 raised to power minus 3 because of milli. Milli means raised to power minus 3. And that is why we are having raised to power minus 3 times 0.008 times 10 raised to power minus 6. Because micro means raised to power minus 6. So you get this sorted out and simplify. 2 shift pi root bracket 0.2 times 10 raised to the power of minus 3 times 0.008 times what? 10 raised to the power of minus 6. You close it. So you will be getting 7 point. Now, inverse of whatever you get here, inverse of it will be giving you 1, 2, 5, 8, 2, 3.03 watts. Yes. I said, if you don't want to do it the way we did it just now, you just multiply. Once you multiply, you get the square root. You can do it 0.2 times 10 raised to the power minus 3 times 0.008 times 10 raised to the power minus 6 times 2 shift pi, then inverse because of 1 over 125,823.03 hertz. We have gotten our resonance frequency of the circuit because they gave you this and they gave you this. Then the question is an amplitude of alternating current at resonance. What do you mean by amplitude of alternating current at resonance? If you are looking for amplitude of alternating current, they gave you the one of voltage. Amplitude of alternating voltage. You say amplitude of alternating voltage is equal to what? Amplitude of alternating current times R. What is this your R? This is where a lot of students are making mistake, because they say amplitude of alternating current at resonance. Remember that at resonance, impedance will be equal to square root of R square plus what? XL minus XC all squared. When we are having RLC what? Circuit, impedance become this. Impedance is the overall opposition to the flow of electric current for RLC. Now, because XL minus XC is 0, how did we get it? XL minus XC is equal to 0, and that is why we say XL equals to XC. We said that at resonance, XL is equal to XC. That means bringing SC inside means XL minus S equals to 0. That means at this point is equated to what? 0. So this is like telling you square root of R square plus 0 square, and 0 square is 0. Square root of R square is now R. That means amplitude of the alternating at resonance means that the R we are seeing here will be the R given to you in that question. So the voltage is given as what? 3. So we now say 3. We now say 3 equals to I what? Bracket what? 10. Okay? So that means the amplitude of alternating current at resonance will be equal to I equals to 3 over what? 10. 3 over 10 equals to 0.3 watt amperes. That means if you are having your voltage at 3 volts, your current will be at 0.3 amperes. Having it in mind that at resonance, XL minus XC equal to 0. That means here will not be 0. We will not put anything there. So we just put it to be 0. So R square plus 0 square will give you R square. Square root of R square is R. That means the impedance when we are talking about resonance, the impedance when we are talking about at resonance is equal to the resistor given to you. So that means ordinary and not meant to do this. But it's just because I want to explain how I got that at resonance that the what opposition to the flow of current will be offered by the resistor only. Yes, at resonance, opposition offer or overall opposition to the flow of electric current will be offered by the what? The resistor only. When you say at resonance, but at ordinary RLC circuit, when they didn't tell you about at resonance, they say that Z is equal to square root of R square plus XL minus XC square. But when we talk about at resonance, this will be equal to 0, giving you the impedance to be equal to the effective resistance of the resistor, and it is given to you as 10. So you just say I equal to 0.3 amps. Now let's see how to solve this question number 6. An AC source is defined by the equation V equals to 300 sin 100t. If the circuit has 10H inductor and 8 ohm resistor, determine the period and frequency signal, the root mean square voltage of the voltage. Now if you are given this question, remember that when we discuss this theory of this alternating current circuit, we said that if this is the circuit, if this is AC circuit, we said that here becomes your what? Peak voltage. The maximum what? Voltage become your peak voltage or maximum voltage. But at any point, we'll be getting V. Ordinary voltage that is not at the what? Peak or maximum. At any point, you will be getting your V. Same with current. And so we said the relationship between this V you are seeing and this one that is at the peak is, we say V is equals to VO sin WT. We say that where W is equal to pi what? F. Okay? That means comparing what we have here, V equals to 300 sin what? 100t. Therefore, VO will be equal to 300 volts. Then your W will be equal to what? 100. 100 radian. Radian per second. That is angular what? Velocity or angular frequency. Now, if you have gotten this, VO equals to this, the question is find the period and frequency signal. That means I will say equate this W with what we have here equals to 100. That means what we'll be having here will be that F will be equals to 100 over 2 pi. F will be equal to 100 over what? 2 pi. 2 pi radian. So what we'll be having is 100 divided by 2 pi will be giving us 15.9 per second. Because radian, this is radian per second. So radian will cancel radian. It will be remaining with 1 over second. Or 15.9 hertz. That is your frequency. Now remember that your period is equal to 1 over F from principle of waves, because this moves in a wave-like pattern. So we will be saying that 1 over F means 15.9 inverse. Inverse of 15.9, that will be giving us 0.063 seconds. So your frequency is 15.9 hertz and your period is 0.063 watts seconds approximately. Then the root mean square voltage, since we have gotten our peak voltage or maximum voltage, and we noted that V root mean square is equal to VO all over root 2. That means our what? V root mean square will be equal, what is our VO? 300 over what? Root 2. We'll write 300 divided by what? Root 2. That will be giving us what? 212.13 volts. So we have gotten our period, our frequency, our root mean square voltage of the what? Voltage. That means from equation given to you, you can calculate anything. If they ask you to find the inductive reactant, for instance, if they ask you to find the inductive reactant, we have gotten our frequency. You just say inductive reactance is equal to 2 pi L. They have given you your L, and we have gotten our frequency. Just multiply by 2 pi. So this question just say get the period and frequency, get the root mean square voltage. So that is where we stop. These are what? Root mean square voltage. These are peak or maximum voltage. These are what? Frequency, which unit is in hertz or per second. And these are period, which unit is in per second. And that is how to sort out this question.